In our instructional video today, a little bit about creating contacts from points. So in this case we have some lithology data, setting up a boundary just to encapsulate all the data that we have, and we have some selection of the lithology information already available. So that's what we're going to use to extract contact points at the end. So we'll give it a name. In this case it's unit 1, and we use those manually selected segments, also labeled unit 1, and we just want to have the starting points. So that's what we're extracting. So we're running the process and we can check that we have all the points available. What we want to do is create a good looking surface that fits nicely through all those points. So typically you would use the planar surface from points for this, and as a first step we'll actually use the default settings, which you can see has a 25 meter grid cell size. So for this example the 25 meter is quite small. It's very small compared to the project size, and you can see that the triangles are actually maybe a bit too small for the result to be useful. We increase that to 75 as a first step. And what you'll notice is that the bumps that we saw initially have largely disappeared, while still honoring all the points in the selected data set. So this is a good first step to make sure that the resolution of the surface triangles matches the actual data. But we're not quite happy with this surface yet. We want to get rid of the bumps a bit more than we have. And typically this is what you do with the smooth and snap surface. So internally when you're running the planar surface from points, it uses the smooth and snap as well, but it just uses a few iterations, mainly for speed purposes. But as you can see, if we increase this to about 50 iterations, the surface between the points starts to even out a lot more, and while still honoring all the points. So we increase it up to 100 even, and you start to see a surface that nicely fits through all the points and doesn't have all the bumps. And just to illustrate the effect that we have after this smooth and snap compared to our initial surface, we'll just turn the initial surface back on as well, and we turn off the triangles on this one as well, so we can compare the end results quite nicely. And you also notice some of the sort of crevasses in the original surface have completely disappeared in our end result. So in both cases we have surfaces that honor the points, but the end result of the smoothing is a lot nicer than our initial estimate.